Hello and welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. In this video, I want to talk to you about some special methods that can be put inside of classes. Things that Scala allows you to do that either it treats differently than normal methods or that are things that you generally can't do in a lot of other class-based object-oriented languages. And really, these few things that I'm going to show you are a big part of what makes Scala so powerful as a scalable, flexible language. One of the great advantages of Scala is the fact that so much of the power is present inside of libraries instead of having to be put inside of the language itself. For example, arrays are just libraries. So are the lists that we've looked at. We'll look at other data structures. Whereas in other languages, many of those things would have to be included specially in the language. In fact, in most languages, they are. In Java, for example, an array is treated differently than any other type of collection to hold data. In Python, you have different types for your what they refer to as lists, which are variable length arrays, and your dictionaries, which are a type of thing that we'll talk about in a few chapters called a hash table, or a map data structure. So how do we get this flexibility? Well, it comes in a number of forms, and in some ways to demonstrate this, what I'm going to do is I'm going to we'll write a class called vector. And this vector is going to be immutable, and it's going to have, this will be a vector in 3 space. So actually, how about we call it a vect3 for that purpose. X is a double, Y is a double, Z is a double. And as you should recall from the previous 2 videos, if I want these to be visible outside of this one instance of the object, I need to either make them vals or vars. And I want to make my vec3 immutable. So I'm going to make them all vals. Turns out there's some significant challenges that I'm not going to go into in depth here, but some of the things that we're going to do would start to become difficult for programmers to think about and to work with if we made these things into vars, as we also saw in the last video. Making them vars, we'd probably want to make them private. I want everyone to have access to X, Y, and Z. Plus, because they are vals of an immutable type, there's really not much of a problem with making them public because they can't be changed. So one of the things about a vect3, and the reason why I picked this, is because a vector has certain types of operations. It's a mathematical entity. And this allows us to introduce one of the first kind of special things that you can do. And that is the fact that Scala accepts names that are different than what a lot of languages accept, in that you can use operator symbols in your names, at least in certain ways. Okay, so we've typically done names on our variables, on our methods, on our classes that combine just letters and numbers. And specifically, what you're allowed to do is you can have letters, numbers, and underscores inside of a name. It has to start with a letter or an underscore, and it's generally recommended that you not start with underscores. In fact, you might have noticed that I don't use underscores pretty much anywhere in my names. There are some special places that we'll see where they can be useful. In addition to that, Scala has 2 other possible options for names. So what I just described is basically the naming scheme that you get in a language like Java. But Scala allows a little bit of additional flexibility. And one of the things it allows, for example, is you can make a name that is just a combination of operator symbols. So for example, plus is an operator symbol, so is minus. And you can make arbitrary combinations of these. So you could make a method named plus minus plus if you had a really good reason to, and that's something that is worth talking about because most time you shouldn't do this. But in the case of a vector, there's a very well-defined definition for adding two vectors together. So we can write plus, and we can pass in a second vect, and the result of this is going to be a new vec3 whose x component is x plus v dot x, whose y component is y plus v dot y, and whose z component is z plus v dot z. Okay. So that's the definition of plus. We could also make a minus. And what this really allows us to do is, in fact, okay, let's real quick go in here and let's def write a little method that just makes this so that it kind of looks pretty. Okay, and so now equals, I can make a new vect3, new vect3, 1, 2, 3, val v2 equals new vect3, 3, 2, 1, and I can print line v1 plus v2, and let's v1 plus v2 dot print form. Okay. And if we run this, you can see that when we add these two vectors, we get what we would expect, which is 4, 4, 4. Okay, so the real advantage of these names is particularly for things that have mathematical very nice mathematical definitions. You can use the plus, minus, star for multiplication, the slash for division, so that your library code looks like it's actually something from the language. As I said, you don't have to use just a single symbol. You can use multiple together. Now, this is where you have to be very careful. The plus side of being able to do this is that if you name something, for example, plus 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 or plus minus plus, when someone is reading the code, they're going to look at that and go, what the heck is that? And because they don't know what it is, they'll have to go look it up. Now, in many situations, it's probably better to have, unless the symbol is easily readable and easily understandable, it's better to use an English name. Okay. So in the case of vectors, there are two other operations that we might want that are both products. Okay, there's the dot product and the cross product. And the dot product returns a scalar, a double for us in Scala, and the cross product returns another vector. And this is where things get potentially interesting of what do you call these? What do you call a dot product and a cross product? And you could do weird things with, so maybe you want your cross product to be called star star and your dot product to be star plus star. There could be reasons why you might want to do something like that. I would typically shy away from that. And the reason is simply that when someone is looking at your code and they try to read it, those types of things are going to be confusing. Unless the set of symbols that you pick is really the invocative of what is used in, for example, mathematical notation, or if it's just so easy to understand. So, for example, you might have seen the fact that you can concatenate two arrays or lists with plus plus. When someone's reading code, it turns out that that's pretty darn easy to understand what's going on there, and so that's probably acceptable. But in the case of a dot product and the cross product, quite honestly, I would rather call them dot and cross. So the dot product is x times v dot x plus y times v dot y plus z times v dot z. It's the sum of the products of the components. And the cross product is a bit more complex. It's going to be a new vect, no capital N on the new, and it has the three components in here. The x component is going to be y times v dot z minus z times v dot y. That should be a v. The y component is z times v dot x minus x times v dot z. And the z component is x times v dot y minus y times v dot x. Close that off. And that defines the cross product. And doing this, because you can use the operator notation with things that are not, oops, I'm missing a 3. Because you can define these with things that, because you can use this type of notation with things that aren't just symbols, this is still fairly easy to read. v1 dot v2 is fairly straightforward. The one challenge here is associativity. And the way that Scala does associativity, or that not associativity, that is precedence. So you've probably noticed that Scala does precedence the way that you were taught to do precedence. Multiplication comes before addition or subtraction. So multiplication and division come first, addition and subtraction come second. They are also right associative, so they start with the highest. If you have something plus something plus something plus something, it starts from the right and does that plus first, and then it goes off and moves to the left. And so those are the normal rules. And so the book has a nice little table of what the different operator symbols are and what their precedences are. And it follows what you would get in most programming languages. The difference is in most programming languages, all that you would have is those symbols. And in Scala, if you were to create a method, this, by the way, would be a horrible method name to make because no one would know what the heck this was. And the question is, well, if you were to actually create such a horrible method name, what would the precedence of this be? Because it includes multiplication and addition, subtraction. It turns out that Scala decides it based upon only the first character. So because this starts with a multiply, it would have the precedence of multiplication, which means that it would happen before addition operators. Also, if you want, instead of being right associative, if you want to be left associative, so you want it to group from the left and go to the right, any operator that ends in a colon does that. And if you think back, you should remember that with lists, the cons operator does exactly that. It is left associative. So if you do, for example, the expression that you are probably used to is something like A, cons B, cons C, cons nil. And because these operators end in a colon, Scala sees this. Okay. Whereas if you do A plus B plus C plus D, if it doesn't end in a colon, it works this way, and so it binds the first from the left and then goes to the right, whereas the operators that end in a colon do the opposite. Okay, so those are some very general rules. What about this dot? Well, it turns out that everything that starts with a letter is lower precedence than any of the symbols. Okay, so this dot would have very low precedence, and that is contrary to it being a multiplication. So that is something that you would have to keep in mind. You would need to put parentheses around this anytime that I wanted to do. So let's just assume I have a V3. If I were to do this, and it doesn't matter what spacing I put in here, Scala would do the plus first and then the dot second, because the plus has higher precedence than a letter does. And that's just how the rules work. But by giving you this fairly simple set of rules, Scala gives you a lot of flexibility in stuff. There are other operators that we were able to do on things. So we've demonstrated here plus, and we could do minus, dot product, cross product. Other operators that people that you use are unary operators. So for example, if a is an integer, well, you're allowed to type in minus a, which does the multiplicative or the additive inverse of whatever the value of a is. Well, that would actually be a nice thing to have with a vector, and we should be able to do print minus v1. That would be a vector going in the opposite direction. And of course, right now that won't work because we haven't defined that. How could we define that? Well, it can't just be a minus, because that's what we did here. And it can't even be a minus with no argument, because then it would need to be v1 followed by a minus. And we want this to be prefix, because these things generally are prefix. So this is a truly special method. In some ways, the normal operator methods, they weren't really special. It was just Scala has a broader set of allowed names. But for the prefix unary operators, this is special. If there is a method that starts off with unary, followed by underscore, followed by the symbol that you want, this will when Scala sees, should do minus, we'll get to see what the level of binding is there. Yep, that's what I was afraid of. We do need parentheses for that print form. Okay, and so it takes and it inverts all of the elements. So this, with the minus sign in front, gets expanded to v1 dot unary underscore minus. And so it calls that method here and then calls the print form on that. This is just a general rule for Scala when it sees a prefix operator. For the prefixes, you can only use minus, bang, and tilde. Those are the only operators that are allowed to be in your unary prefix operators. So the next type of special thing that you can do is property assignment. And it turns out that the vect3d really isn't our best example of this. I'm going to go back to our bank account that we wrote in the last video. And let's just assume, for various reasons, that when I first wrote this, I had been stupid. I had somehow decided to make my balance a public var. Okay? And what happened was I started off making it a public var, and I started using it, and other people started using it, and now there are thousands and thousands of lines of code that have direct access to balance. And I need to stop that. Okay, you're not supposed to be able to get directly at balance. Maybe, for example, we started putting in logging, and this is actually something any bank would want to do, make it so that every time the balance is changed, it logs that someplace so that you can go back and look to see what happened. Well, if I have this as a public var, I simply can't do that. So what I'm going to do is I'm going to make it a private var, and just to demonstrate that this works, Okay, so account.balance down there, and that would have worked just fine with this. We can verify that by running it, and it prints out the 0 at the end. Okay, so that's happy, but I realize at some point I can't do that. I can't allow just anyone to change the balance. And so if I make this private, well, then I have this problem that every line that accesses the balance is now broken. So how can I get around this without breaking a whole bunch of code? Well, one of the things that's interesting about Scala, especially if you know other languages, is that the methods, for example, description, I didn't put any parentheses there. I don't have to. And this is, so for example, in Java, C, C++, the parentheses are kind of essential. They say this is a function call or this is a method. And if you don't have parentheses, it doesn't know that it's executing code. For the reason that I'm about to show you, the developers of Scala decided to take the alternate route and make it so that you don't have to have the parentheses on methods. And one of the advantages of this is that I can just say def balance equals L balance. So L balance here, the L for local, and this is the balance that's being stored inside of here. Now, and I should actually, inside of this code, you no longer refer to the original balance, only to the L balance. Actually, here I can refer to that, especially when you're mutating it. And it still runs. And what was really happy here was that the outside code, the thousands and thousands of lines, you might have to edit a fair bit of stuff inside of the class, but your class should be fairly short. You can have a huge amount of code outside of the class that depends upon it, that is utilizing it, and that's what you really don't want to break, especially in a professional setting, because it's quite possible that a lot of that outside code was written by other people. And when you break other people's code, they don't like you. So it's something that you really try to avoid in most situations. Now, what if I had wanted to do something like this? Or plus equals 50, so that we can't possibly have the error of an overdraft. Okay, well now what does this do? So that would have worked just fine with a var balance, but it doesn't work for this. And the problem is I somehow, remember this is just short for, and this should be, account.balance plus equals 50. Well, that's actually the same as account.balance equals account.balance plus 50. And in fact, that is actually what this will be, what it would be expanded out to, because that's long. We typically just type it this way. So how do you make it so that you can do an assignment to something when that something isn't a var? Okay. Our var now isn't called balance. Our var is called L balance. Okay. We were able to pull off the balance by writing a method that doesn't have parentheses after it, and so that you can call it and act like it's just a var. But it's not, so we have problems with the assignment. Well, there's a special form in Scala for this as well. If you call your method def, the name that you're using for your property, and then underscore equals. Okay. And then what you want it to be. I will go with a newbal. How about is a double? Now, one way to write this would be to say balance equals newbal dot to end. Okay. I made this a double just because I'm following here. ideally, you would have written it all with ints to start with, and everything would be doing ints. But since I had used this code previously to demonstrate that we could change the implementation without changing the public interface, I'm going to stay consistent in the public interface and use doubles here. The problem with this, so this will work. Oh. Just remember to do the assignment to the local variable instead of the name. Okay. Without that, that was actually a recursive call. I do an assignment to balance, and what does it do? It does an assignment to balance, which, yeah, that spins around. So this now works. I could even show that it works by printing the balance out again. And so we have $50 in the account. Okay. However, this whole idea of we wanted to be able to log things. Well, that code would wind up going into deposit and withdraw. And one of the advantages here, so I could technically put logging in here, and so I could just add additional logging. Personally, if I were writing this code, the way that I would do it is to say if new balance, or if new bal is greater than balance, then I am doing a deposit. Else I'm doing a withdraw. Okay. And the advantage of doing this, we'll run it just to make sure that it's still happy. Though I seem to have gotten a different, okay, yeah. The way that these were written, they take an amount and they converted it to pennies. This is going back to that double versus int type of thing. Earlier, I should have been multiplying these by 100 if it was pennies versus dollars. But what's significant here is that if I were to put in code in the deposit, so I do have some code in here. I have code that makes sure the amount, especially on the withdraw, that we can't go negative. Okay, you can't withdraw too much money. Because I've made it so this assignment calls either deposit or withdraw, whatever code that I do for error checking or for doing logging of transactions or whatever, inside of these two methods will wind up being called. Okay. And I could see some people arguing there's some inefficiencies in doing it this way as far as the execution speed, and there are. This is not the fastest way to write this code. However, it prevents me from having to duplicate logging code, and especially if that logging code became very long. Once again, the general rule of you don't want to have multiple copies of the same or very similar code. So that is the property assignment. And we'll come back for the next video and look at two other special methods that wind up being useful. We'll go back to our vect example. We'll also talk about operator overloading. But that's it for this one. So our take-home message, you can name your methods. You can also do this for data, though I would strongly recommend against it. You can use symbolic names, so you have more flexibility in your names, which is really good for mathematical types of libraries. There is a special form for making something a unary prefix operator, and then there is a special form for making things so that you can do assignments. And you can have something that looks like it's a public var. To the outside world, right here, this looks like a public var. In fact, technically, when you declare a public var, Scala generates two methods for you. So for anyone who might have worked in another language, it's often, many other languages, in general, you don't default to public. And some people might find that a little bit unsettling about Scala, the fact that it defaults to public. because a lot of languages will default to something that is far less visible than public. But the reason why Scala can default to public in many ways is because you can do things like start off with a public var, and if you realize later that you need to have some checks around it, you can change the name of the var and write these two methods to basically get the value and to set the value. And all of a sudden, and all of your outside code works because it doesn't know the difference. It doesn't know the difference between calling those methods and actually having a var. But this way, I could have additional code because I'm actually calling the methods. So that's it for this video, and we'll see you again soon.